No, it's okay. You can explain why.
No, I'm not gonna explain
I'm gonna
why.
put it in the video.
No, no, don't do that.
Why not?
Because that's personal.
Uh-huh.
Yeah.
The audience is gonna be so fucking confused. Anyway, guys, Ultrakill, right? Yeah, you ever played Ultrakill before? I played Ultrakill before.
I haven't played Ultrakill before.
Okay, so we're laughing.
What do you mean?
You're laughing.
I've never played.
Okay.
I know nothing. Why are we in the desert?
Yeah, good enough.
Yeah.
So you like stars, right?
Okay.
You like stars.
Yes, I love
Do you want to talk about some silly things about stars?
Me?
Yeah.
I don't know what silly, like, prophecies about stars. I just like the shine bright like a diamond. I don't know what the fuck I was
That's a
going
reference.
for. I like the combo of
Where's the
like
drone?
navy background and like gold stars.
Where's the truck? Awesome.
Wait,
Awesome.
wait, did he actually go?
Yes. That's so cool.
That's brilliant.
That's so. Thank you, Ultrakill.
It's they're coded so well.
Yeah.
Is my hair getting in your face?
No, it's fine.
Oh, okay, never mind.
Anyway, stars, right?
Stars. I know neutron stars, but do I know what they are? No.
They are just stars.
They're just. Oh, I thought like you would elaborate on like the stuff.
Okay, I will
stars.
elaborate for lasagna because this will be really funny because neutron stars, science, every so often, right? Scientists will go they'll be a little bit quirky, a little bit whimsical, and they'll name something some absolute bullshit, right? And Ultrakill players will know this from the Minos Prime bacteriophage that exists, and everyone knows about it because it's it's like prior names or whatever. I'm not making this up. Prior names is the corpse of King Minos. Get it? I'm fucking serious. You can look it up.
I am willing to believe that's the only piece of biology that you will ever know.
Yep. But anyway, scientists get a little bit silly sometimes, right? And neutron stars are kind of an example of that because they named the whole thing after pasta.
That's part of nuclear pasta?
Yes.
Oh.
You may have heard of nuclear pasta before, right? That's what a neutron star is. You have different layers of a neutron star, right? Where it gets like thicker and thicker. Then just different pasta names. There's like the linguine phase and like the
lasagna phase, and there's a spaghetti one, and I forgot the other one.
The lasagna phase is the final phase, I believe. Because would you believe the particles start looking like fucking lasagna because they get so tightly packed together. Anyway, we're jumping ahead, right?
Everything turns into lasagna at some point.
We're jumping ahead.
Let's look it up.
No, it's fine. I have like a vague enough understanding of my noggin.
Do you remember all of the different types?
Absolutely fucking not.
John, you know 3 of them.
Never take any of what I say as fact because I am a guy on the internet who is just saying stuff.
Alright.
But anyway, you could take this as fact. A neutron star is just a core of a star.
Oh.
It's just a star. It's basically... It's not just the core of a star, but it may as well be. Technically, a dwarf, a white dwarf is just the core of a star. But a neutron star is essentially a star if you took it and packed it into a really small area. Like a really small area. Like I'm saying, like you take a whole star and you pack it into the size of London.
Oh.
Like a whole star.
That...
Usually a pretty
Yeah.
fat one, right? Bigger than our sun. A lot,
course,
like
of
quite a lot
course.
bigger than our sun.
Of course.
And you put it into a space the size of London. You don't lose. It's not like a supernova where you lose a lot of the star and you're left with just the core. No, you keep most of the star.
Ah.
Most of the star is still there. In a space the size of London, right? Or, just an average, pretty reasonably sized city. So it's pretty fat. It's pretty dense.
Oh, okay.
There's a lot of star there. There's quite a big amount of stuff. Good job, guys. Great job, team. There's a lot of stuff there, would you believe? And this leads the particles, usually particles inside of stars, right, are very densely packed, which is how they fuse and how they, burn bright, right? Like, you just pack them real dense and shit. Not even close to a neutron star. It doesn't even compare, right? This is the funny thing about particles, right? Is someone somewhere may tell you that particles are 99% nothing. This is true.
This is true.
This is true. Technically, if you want to be a bitch and pedantic about it, they're actually 99% electron field potential clouds. But shut up. Shut up. Right? Shut the fuck up. They are basically nothing. Okay? You are not Schrödinger. You are not a pedophile. Schrödinger was a pedophile.
Oh, okay.
No one really knows that. Also, a lot of physicists from like the mid 20th century were really bad guys.
That's crazy.
A lot of them were really into eugenics.
That's okay. That's
yeah.
I thought you said that was like a trend among like.
Oh, it is.
Prize.
Winston Churchill also won a Nobel Peace Prize and was into. It's don't look up the stats of what Nobel laureates do in their free time. It's fucking weird, man. They're a bunch of freaks. But anyway, so anyway, electrons, like atoms are mostly nothing, right? Mostly nothing. 99% nothing. Why do you think a neutron star is called a neutron star?
Made up a neutron.
Uh-huh. Ding, ding, ding. Correct.
Wow.
Normal atoms aren't made up of neutrons. They're made up of protons, neutrons, and electrons.
Yeah.
So why the fuck are neutron stars made up of just neutrons? Well, that is what neutrons are, yes.
Yeah.
But like, come on, think about it, right? Think about it. It's not that complicated.
What?
Why is it just neutrons?
Because like protons and electrons, don't they cancel each other out? So like,
You're close.
I'm close.
You're close. You're like pretty close.
I don't know where to go from that. It's like if you just don't have it, it would still be like fine.
Protons and electrons cancel each other out in a normal atom, so you get, so like they don't get charged, right? In a normal.
Oh, there's no charge?
You get ions. You get ions, which are just charged atoms. But hey, I dashed.
Wow.
And you get ions. So, normally, right? You have protons balancing out with the neutrons to get like a no charge. Awesome, dude. Ultrakill's boss fights. But anyway, yeah. So in a neutron star, right? You know how I said there was everything's a neutron.
Yeah.
What happens if you get a plus, and you put a minus next to it, right? A +1 and -1.
0.
Uh-huh. So in a
it's
neutron
just
star,
zero.
the protons and it's pushed together so fucking tight
What?
that the electrons fuse with the protons and make the charge neutral, and turn them into a neutron.
Ah.
Yeah.
Ah.
So a neutron star is made up of primarily neutrons,
Ah.
which is why it's called that.
Ah.
Remember when I said that atoms were 99% nothing?
Yes.
Yeah.
Oh.
That's how hard they get, like, the difference in scale between
Oh, no.
an atom, right? An atom and the nucleus, right? Or like a proton, which is
Yeah.
what fuses, right?
Yeah.
The outermost electron and the innermost proton is basically the same kind of scale as the Earth to the moon. It's on the same order of magnitude as the Earth to the moon, about 100,000 times difference. Which, you know, you might be wondering, that's fucking crazy. Well, that is roughly, not roughly,
Rough estimate.
very rough estimate, because it's like I believe an atom is 10 to the -10 meters and a nucleus is 10 to the -15. I believe.
I'm so glad I don't need to remember this.
I didn't need to remember that, but it would have been useful. I think I'm right. If I'm not right, I'm close. It's like a stupidly, it's insane.
Do you want me to look it up?
Nah, it's fine.
Okay.
This isn't important information anyway. Let's be so real. Like, this is
bad.
not. If you get misinformed, low key, it's not like.
Why are you getting your information from two like
True.
idiots on the internet?
But anyway, right? The scale, the difference in scale we're talking about here is fucking huge. And they get crushed to the point where the protons and the neutrons, protons and the electrons, get pushed into each other.
Make neutrons.
That's like if something pushed you so hard, you suddenly got smushed into the moon.
I don't think I'd enjoy that.
No, and they don't either, which is why they stop to fucking exist and become neutrons. So anyway, right, that's crazy, right? That's insane.
Yes.
They then, in the lasagna layer, get pushed to the point that individual atoms are now touching each other.
So we skipped to the last, like...
Yeah, because the rest of them are who gives a f. I went into the same fucking door. I just...
You don't want to know about the spaghetti phase?
to be fair, like the most interesting one is the lasagna phase.
Okay, fair enough.
Because that's where, like,
yeah.
you're on, like, the border of becoming a black hole there.
Oh, okay.
Essentially, is what's happening.
Is that why you learn about the lasagna?
No, I don't. We haven't learned about this in class. It's
You
just...
don't learn? Oh, you just know this?
Yeah, because it's cool.
Damn, that's fair.
But, like, anyway, right. The atoms are literally smushed together. Like they are touching, essentially. That's why it's called the lasagna face, because it looks like a lasagna. Atoms are not meant to be touching.
No.
Right, you know those models you get in school of, like the solid, like, formation, and it's a bunch of circles touching each other? That is not how that works. That's not how that works. They're not touching.
Oh, do you mean, like... No, never mind, I'm thinking...
Like, you know, you draw the box with the circles in it, and you're like, that's how a solid looks.
Oh, okay, never mind.
No, they're not touching. If they're touching, something's gone wrong. Something's gone real wrong. But anyway, they start touching. Which is kind of fucking crazy. Right? That giant space that was in between atoms, no. Gone. They've been smushed so hard.
I'm into lasagna.
Yep.
What does... And then that's bordering a black hole?
The thing is at this phase, right, this is like the critical point for forming a black hole. Either what happens is you get something called neutron degeneracy. Which is where, like the neutrons are packed in so tightly that they exert a pressure, which stops them from getting packed in any tighter. There's a lot more to it. It's very complicated, and I really don't know what I'm on about there. But that's like that's the basic gist of it, right? So many neutrons so tight that they go fuck off, right? But if that doesn't happen and the star has enough mass to smash through neutron degeneracy, it will turn into a black hole.
Ah.
A neutron star is like the most insane thing that isn't a black hole. It is like the last thing. Which is kind of cool. Where's the sentry? Oh, hi, dude.
Hi, dude.
Squash.
Squash?
Squash.
I don't think they're made of squash.
Why are we flying?
Why can't they fly?
Poor guy.
Okay.
Anyway, yeah, but neutron stars are pretty cool.
Yeah.
You would absolutely... The thing about neutron stars is they're so tiny, right? They're so teeny tiny, but they will fling entire solar systems around like they're nothing.
Ooh.
Like, you could have, like, a huge star, and it could get... Like, the sun would get flung around by pretty much any neutron star.
Oh.
Because the sun, frankly, is not that big. The sun is really disappointing. It's called a dwarf star. It's, like, the most, like... If there was average on the label of a star, the sun wouldn't be it, but it would be close.
Close?
It'd be close.
Ah.
The average star is called a red dwarf.
Ah.
Would you believe, right? It's red.
Are they massive?
No.
Okay.
That's a red giant. Two different
my
things.
bad.
Very different things. A red dwarf is essentially like the sun, but smaller.
The sun, but smaller.
Yeah. And it glows red because it's not very hot.
Ah.
Yeah.
Our sun is
Yellow.
yellow. Okay.
Technically, if you actually like look at it, it would be white, but like it predominantly is yellow.
I thought it was orange.
No, it's yellow.
Okay.
There's a difference.
Okay.
There is a difference.
Okay.
Right? There's a whole chart. You can look this up. It's called a Hertzsprung-Russell diagram,
I
right?
think I remember this.
It's a really cool chart, and it's not that hard to understand when you look at it, because a lot of them will be like very pictorial and have like images of what star goes where, which is really cool. And you can see there'll be three sections, right? There's a section in the middle called main sequence, which is what most stars are. The sun is main sequence. Red dwarfs are in there. They're at the bottom of main sequence, right? They're really small. They're not very hot. And it will go up in this diagonal line as you get hotter and hotter and bigger. And the lifetime also goes down. And then over off in this little corner are red giants and red supergiants, and over off in another little corner are white dwarfs. It's a really cool diagram. Maybe I'll put it on screen. I don't know. And I'll like point out what I'm. The point being is it's cool. And the sun, right, is like it's at the bottom. It's all you need to know is all of the lame shit is in the bottom right. The sun's in the bottom right. All of the cool shit's in like the top. Sun's not up there.
No.
But most stars are actually red dwarfs. because they're small. Would you believe? And it's easier to form small stuff.
Oh.
And the smaller a star is, the longer it lives for.
Oh.
Like exponentially longer. Like it's crazy.
Dang.
Like the sun will live for like a few billion years. Peanuts. Peanuts on a star lifetime. Red dwarfs can live for like trillions. Genuinely trillions of years. And the hottest and brightest stars? A few million, if you're lucky.
You're lucky.
So like it's like an exponential thing. The hotter you get, oh boy, it's cooked, buddy. It's so over. But yeah, but those are right. So I'm telling you, right, most stars are red dwarfs, right? So you probably think, right, when you look up in the night sky, most of the things you see are red dwarfs. No, because they're not bright enough.
Yeah.
The only thing you're going to be seeing predominantly in the night sky are really bright, big stars that realistically probably don't exist anymore.
Oh yeah, because it like takes.
Because it takes time for the light to travel, and those are big stars, and they probably died a while ago.
Yeah.
Although actually no, probably not actually no, because all of the stars you see in the night sky with your naked eye will be like very, quote unquote, very close to Earth.
Oh.
Very close being like a few million light years.
Okay.
So they probably would still be around.
Oh, okay.
Yeah.
Is it like if you're looking through telescope or?
Very much. Telescopes are not like they're funky.
Yeah, no, I don't know much about it, but
A regular like telescope that you're thinking of will probably only let you see something you could already see,
okay,
just a little bit clearer.
I kind of thought like the very large telescope stuff.
That's
like
the
that.
kind of bullshit where it's like you are leaving that telescope on for months at a time, in some cases, so you can gather as much light as possible from these unimaginably dim stars.
Okay.
And because you just gather a shit load of light over a long time, they become bright. Yeah. But anyway, you wouldn't do that. Point being is all the stars that you can see in the night sky are like weird. They're weird. They are weird stars. They are big, they're bright, they're weirdos. And you know, like you look up at like a constellation, most constellation, I think it's like a pretty solid percentage of stars. It's like 10% or something. A very vague number. Don't take that as fact. But it's something around that. Or all stars are red dwarfs.
All stars.
Yeah, all stars.
All stars.
Yes, all.
All stars.
There's a lot of classifications for stars. There's like 15. There's a lot. Maybe not 15. There's a lot of classifications for stars, and red dwarfs make up like a solid like 10-15% of them. Stars like stars like the sun are relatively common. You know, like a few percent here and there. But if you look up at like a constellation, like Orion or something, or like the Big Dipper, it's mostly big, bright, hot stars, giant stars, you know. Weird shit. Yeah. Because the biggest and brightest stuff is what you can see. Like a famous star, like Betelgeuse. That is a red supergiant. Those are very rare.
Betelgeuse is the star or the
Star.
A star. Okay, I was about to say,
Spelled
like, I don't
not.
remember.
It's not spelled Betelgeuse. It's got like a G, a U.
Yeah, G
Okay,
E U
dude,
E S E, something like that.
Thank you. But yeah, that red supergiant, and in the same constellation as it is Rigel, which I believe is a very hot white star. Like a bright blue, hot, big, fat boy.
Blue.
Yeah. If a star's blue, it's not living for very long.
No, I assume.
Yeah.
Would white? Is it white hottest or is it?
You don't get white, like you don't get purely like white stars. They will
Okay,
give off
okay.
like some kind of.
Blue?
A white star would be like a white dwarf, but that's because it's not a star anymore.
Ah, okay.
Or like a neutron star. But you know, like a bright like blue or like violet would be
Ooh, okay.
like the hottest stars.
I like violet.
Yeah.
I like purple.
Too bad they're literally killing themselves.
That makes sense.
Yeah.
Yeah.
Yeah, it's unfortunate.
Okay.
But I don't know, it's just cool. Like you look up at the night sky and it's like, man, that is not what stars look like. There's a bunch of weirdos up there.
What do you mean that's not what stars look like?
Like when you look up at the night sky, that's not what most stars look like.
They don't look like giant bulls.
They're not that color.
Oh, they're not that color.
No, they're red.
Yeah.
Like if a red
Right.
dwarf was visible in the sky,
Oh.
you wouldn't see it in the night sky as white like you do every other star. It would be red.
But you don't see.
But you don't see them because they're not visible.
Yeah.
It's just the other stars are like they're so bright. Like they're just so bright that to our eyes it looks white.
Ah, got it.
And it's been over like such a long distance, like you just can't discern the difference.
Yeah, no, I kind of figured like, oh, it's just really far away, so it's just you're not gonna tell,
No,
can you?
but if you could see a red dwarf, if you were close enough to see it in the night sky, it would be red.
That'd be cool.
Yeah,
It'd be like, what is it? 773?
yeah.
Yeah.
Technically, that is what the sky should look like.
If we could see them,
Yeah,
if they were bright enough,
yeah.
but they're not.
But yeah,
Wow.
but they don't. If you were in like a, I don't know, like a nebula or something, there'd be so many red dwarfs.
Ow.
Also, I think I've mentioned this before, but most stars come in pairs. Most, yeah.
And then like they just circle around each other.
Yeah,
Yeah.
which is another reason why the sun is a fucking weirdo.
I like our sun. We get to live because of it. Goddamn.
The fact the sun is lame and boring is why we get to live. That is, like, that is actually...
And sun's quirky and not like other girls.
The sun is, like, the limit of, like, a star that could sustain life, realistically.
Yeah.
All of the other ones are, like, too big, too bright, won't last long enough.
Red dwarfs aren't bright enough.
Red
What?
dwarves are perfect.
Huh? Oh, I thought
They are
I
ideal
thought-
because of how long they live.
Oh, I thought like it wouldn't be bright.
No, you just have the planet closer to them.
Oh, okay, got it.
They're actually better because they also give off less, like, ionizing radiation. Like, a lot less.
Damn. Why can't we live next to a red dwarf?
Yeah, you wouldn't get sunburnt as much.
We don't get.
No, but, like, you'd never get sunburnt.
And
Less.
less.
Not much less, but, like, you know, less.
I'd take less. Less cancer.
Yeah.
Yeah.
But yeah, it's just like in theory, a red dwarf would be the ideal thing to live around
Yeah.
because it just lasts for such a long time. What the fuck is still alive? Oh, never
Is
mind.
this why people think aliens?
Oh, aliens 100% exist.
Oh.
Like, that's not like a conspiracy theory thing. It's just the universe is too large for us to be the only ones.
Ah.
Now, whether intelligent life like us exists is an entirely different question.
So it's just like an old bunch of bacteria. I'm like,
Yeah, like I would say it's like 100% chance that there are bacteria out there somewhere.
that probably makes sense.
Like it's probably more than like. It's pretty like, you know, it'd be hard to find. Do you know how hard it would be to actually like just find that? It's like the best we have at discovering life on faraway planets is, there's like some weird molecules in the atmosphere, and as far as we're aware, oh my fucking god. But yeah, our current best leading way of discovering life on other planets is, weird molecule in atmosphere. As far like that's produced on Earth, and it's not naturally produced on Earth.
Ah.
But like it could just naturally be produced on that planet. You know, the universe is fucking infinite, right? Like I think like somewhere I read there's like someone found like glucose in an atmosphere.
Glucose.
Yeah,
Wow.
like you know, a sugar that life makes, but it's like that's a sugar that our life makes on our small rock, and it might be produced by some fucking freak of nature on some other planet with entirely different rules to Earth. You know,
Dang.
so like it doesn't mean shit. And we will realistically, the answer of is there aliens out there is we will never know.
No.
The only way we would ever know is if we find some bullshit in our solar system.
Yeah.
And if we find some bullshit in our solar system, oh boy, it's cooked. It's so over if we find bullshit in our solar system.
Why?
Okay, so currently, right, life is very rare,
Yes.
right? We don't see any signs of life at all ever, even though we try, right? And we try reasonably hard to find signs of life. Nothing, right? Nothing. If we find signs of life in our solar system, that means that 2 out of 8 planets had life. A quarter of planets in our solar system had life, which means you could now infer that a quarter of all planets could potentially have had life at some point. So why is there no life?
So if we discover life with bugs.
It's basically it's not that we're fucked, but it's the question of, oh shit. If life is this common that there are 2 examples in one relatively small solar system, where's the rest? What happened to them? Because there can't just be this freak of nature in our specific solar system where this incredibly complicated thing appeared not just once, but twice. Right, it must be much more common. So where is it? There's a name for this. It's called the Fermi paradox. It's like a really famous paradox if you're a nerd. It's basically saying like if like, you know, where the life go? Why no life if universe big?
Oh, never mind. I was thinking of something else.
Yeah, you probably were.
Yeah.
But yeah, it's essentially the question of why no life if universe big? And the question is essentially, some shit's blocking it, right? Something must be blocking it. We don't know what. Maybe it's really hard for that initial, like, cell to form. Maybe it's really hard for two cells to merge. Maybe it's really hard to sustain life for a long period of time. Maybe life just stays as a bunch of cells forever. And it's perfectly okay doing that. Maybe life stays in water forever, and it never goes on land like we did. Or maybe intelligence never exists, because it's really hard to do that.
Yeah.
Or maybe every intelligent creature that ever exists kills themselves. That's like a genuine, real, like... That's like an actual theory that people have suggested, which, to be fair, from the sample size of one.
Sample size of one?
The sample size of one that we have, which is us.
Oh.
Not a crazy conclusion to draw.
No, there is, I think, statistics of, like, the smarter you are, the more depressed you're likely to.
It's less depressed, and it's more just them being like, yeah, we did make nuclear bombs, huh? Yeah, we are heading for a climate crisis, huh? And then them extrapolating with, if there's other intelligent life out there, maybe they do the same thing. And then eventually they, end up killing themselves.
I more meant, like, right here, that's sort... I don't know if it's a real stat, or if it's just, like, some weird correlation bullshit, but, like, yeah, I guess you could extrapolate from, like, we did this, and
it's more so just them like looking at the anyway. Point being is if we find a bacteria on some other planet, oh dear, if we find like signs of an old ancient civilization, yikes, dude, something's about to go real wrong, and we have no idea what or where or why.
Ooh.
Which is bad.
Yeah.
So that's why if you ever hear of aliens existing, they don't.
They don't exist.
They definitely do, but we just haven't found them.
Oh, they're not like what we expect.
No. Oh, absolutely. You know how like everyone makes aliens in like video games or movies and stuff, and they're all humanoid?
Yeah.
Like, why would an alien look like that? You could not the reason it look like that is because it's easier to do.
Yeah.
But the real answer is you could never fathom what an alien could look like, because realistically their nature would probably follow completely different laws to us, and that's also probably why we haven't found any aliens. Because we're assuming that life is going to follow the same laws that it has on Earth.
Yeah.
Which like is reasonable. It's worked once, but like, there's no reason it has to do that. There's absolutely no reason it has to do that. For all we know, there could be some life that's based off of fucking like iron. It's just built out of metal, dude. Sentient fucking metal. Sounds crazy,
cool.
but our life is built out of sentient carbon. So like you look like a chunk of iron and you think, wow, that can't turn into life. Look at a chunk of coal.
I turned into life.
Yeah.
Yeah.
That's essentially what we are. Coal is just carbon.
We're just structured different.
Yes.
Okay.
So, hypothetically speaking, on some bullshit planet in the middle of Timbuktu, there could be an iron-based life form.
That'd be cool.
Right? I'm not saying there is. But, you can't say it's not a thing.
Yeah.
You just can't. You can't say that's not a thing.
Yeah.
No, realistically, life is out there somewhere. We will never meet it. Because my little theory is life exists, yes. It's probably all over the universe. The universe is fucking huge, man. Even if there was like 1,000,000 signs of life in every single galaxy, we would never find another sign of life.
No.
The galaxy is just that. There's like, I forget if it's billions or trillions of stars in our galaxy. It's the number's big. Metal pipe sound effect. I think it's like, I want to say it's like a few 100 billion stars in our galaxy? Big number, right? So even if there's life in 1,000,000 stars in our galaxy, that is less than like 0.01% of stars. That's less than 1 in 10,000. I hate to break it to you, we're never exploring 10,000 stars. It's not happening.
I never thought about looking for alien life.
No.
So
But did you see how like fucking crazy it is?
Oh yeah, yeah.
It's like even if there's 1,000,000 different races in the universe that are similar in, or if not, if there are 1,000,000 people who are intelligent like us, you know, conquered their own planet, put shit into space, sent out some radio waves over a few hundred light years like we have, we'd never find them. That's really loud. So we'd never find them. And, you know, that's assuming that there's a million different races in our galaxy alone, which I would put money on there being a lot less than that. I would put Awesome! I'd put money on it being more like, maybe like a handful per galaxy at most. And, like, galaxies are big, man. They're big.
They're big.
You cannot comprehend how big a galaxy is.
No.
Yeah.
I can't even try.
You know how I said earlier, this is probably the only example I can give. You know how I said earlier, right? How like the distance between a proton and an electron is the same between you and the moon?
Yeah. Oh, I thought Earth and the...
Earth and the moon, you and the moon, same thing.
Okay.
Same thing, realistically.
Okay.
Right? The distance between the Earth and the moon is about 300,000 kilometers. Right? Think about, you know roughly how long a kilometer is, right?
Roughly.
Roughly, you can fathom that. So 300,000 of them is already like...
I cannot think that.
Yeah. The size of the galaxy is 300,000 light years.
I cannot fathom that.
No, you can't, because one light year is 9. Is it 9 and a bit? Oh, I'm trying to remember. I think it's times 10 to the 12 kilometers. Which is a few trillion kilometers, I believe. It's a few trillion kilometers. Is it not? I think it's like 9 trillion kilometers.
9 trillion.
I think I could be getting my numbers. I don't think I am. I think it's 9 trillion kilometers. No, I think I'm right.
Okay.
Because light moves 300,000 meters, 300,000 kilometers a second, and a year is a lot of seconds. So, like... Yeah, that sounds about right. 9 trillion times, yeah.
Okay, that's still unfathomable.
Yeah, times that by 300,000.
Okay, still unfathomable.
Yeah, that's one galaxy, and our galaxy is, again, a dwarf galaxy. Yeah.
Great.
Yeah.
No.
Yeah.
We're never leaving.
No! That's why when people say, oh, one day humanity's gonna explore the stars, conquer the galaxy, no, it's not. Never. I hate to be that guy. It's not happening.
Like, humans probably won't live long.
Humans will not leave the solar system. I'm gonna be so real.
Yeah.
They will not leave the solar system.
Yeah.
We might. I think we will very reasonably get to another planet. Probably within our lifetimes if people lock the fuck in. Too bad there's no communists to fucking boost the space race too, but you know.
Mars?
Mars, yeah.
You think of Mars? Okay.
Yeah, absolutely, 100%. Like, we have the technology. If we wanted to lock in, we could go to Mars. We could have done it fucking decades ago.
Oh.
We went to the moon in the 1960s.
Yeah.
The only reason we went to the moon is because a bunch of communists were beating America in the space race, and America was like, fuck it, moon! We win! Even though they didn't. The Americans lost the space race.
Yeah, I swear, like they only had the moon. Everything else they lost at. Yeah.
Yes. Hey man, Americans are my prime audience. Most of my audience in America, you lost the space race, guys. You lost really badly. The Soviets had the first animal, the first person, the first moonwalk, the first satellite. They had the first like fucking everything, dude. The American. Oh yeah, the dog died.
No, I know.
Yeah. But like the Americans said, they basically, the Americans said 1, 2, skip a few. We're going to the fucking moon. Fuck the communists. Lamau went to the moon, did a little bit of stuff on the moon, and then said, okay.
We're done.
And then for the last 50 or 60 years, they have been continually underfunding NASA. Yep. Also, fun fact, NASA really want to use plutonium in their spacecraft because it's like a really, really good energy source. And the American government keeps telling them, fuck off, because it's used for nukes. So yeah, space is currently being like hampered because America is like, me nuke. No space.
Good job prospects.
Yeah. But anyway, I just was funny. It's like we went to the moon in the 1960s, right? Think about that. What tech did they have in the 1960s, huh? How advanced was shit in the 1960s? It wasn't.
Oh.
They went to the moon on a computer that wasn't built out of transistors or ones and zeros. It was built out of thread and rings physically woven together. They went to the moon on that. I think we could go to Mars if we fucking wanted to. It's just no one, like, the governments aren't funding that because there's no super scary communists on the other side of the world to make us, you know, have a fucking ego crisis.
What the fuck is like SpaceX, Amazon?
Literally nothing. SpaceX keeps on blowing shit up and not actually doing anything, and Elon's taking credit for other people's work because he's not fucking. He can't build rockets. Amazon is just selling a bunch of rich millionaires trips to the edge of space. Not even space, really. Just like what is technically the edge of space.
Oh, so trying to commercialize it?
Yes.
Okay.
Essentially. And SpaceX just keeps... They're trying to make a rocket that can land itself automatically. We basically had that technology in the 1980s and 90s. It's called a fucking space shuttle. It was really good at its job. It was really good at its job. So SpaceX have been like making all their like self-landing rockets that land on their own with the power of artificial intelligence that keep blowing up. They're reusable rockets. That's big technology. We're going to ignore that, you know, NASA made a reusable rocket like 40 years ago. You know, yeah. And then we're going to keep glazing Elon because, you know, oh, he made a reusable rocket. No one's ever done that before. Yes, they have. They just haven't made it do it on its own. But even then, he hasn't really done that. He just keeps on blowing them up. And occasionally they work. He's also cluttered space, and he is like the #1 leader of space, like, junk in orbit.
No.
Because of Starlink. Starlink is genuinely a really useful technology.
I don't know what this is.
It is space Wi-Fi.
Ooh.
You can get Wi-Fi beamed at you from satellites in space, and it is incredibly useful. It has given internet to, like, the most remote places on Earth.
Oh.
The problem is there are now, in just a couple years, more Starlink satellites in space than there are satellites in space.
Oh.
Like, Starlink accounts for more than 50% of space satellites, which is a problem. Because there's a lot of shit in space. And we're gonna run out of room.
Yeah.
And Elon doesn't really seem to give a fuck about this because he's making a lot of money from Starlink. Which is a problem. But, you know, whatever. Anyway, if we really want to go to Mars, we could have done that, like, probably decades ago.
Damn.
But, like, because the American government has, you know, infinite money, as we learned during COVID, where they printed infinite money and nothing bad actually came of it.
Wow.
It's a really funny graph. Look it up. Look up the American, like printing money graph. It's like a reasonably, like, flat, steady line. COVID happens, it just goes, woo! And then goes back to being steady. And nothing actually came of it. No hyperinflation because because it's America. Never punished because they're, you know, the world that they are the fucking supply chain.
Yeah.
Anyway, point being, we could go to Mars, like, right now, if we really fucking wanted to.
Maybe not right now.
We could have.
Oh, we could have.
Easily, the technology is there.
Damn. Did put rover?
Oh yeah, they put rovers everywhere.
Yeah.
There's rovers on, like, you know, shit goes on, like, Saturn and shit all the time.
Yeah.
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 It's not easy, but we've got it down pretty good at this point.
Wow.
So, you know, I'm saying we'll go to Mars in our lifetime, probably. If, like realistically, not even if anyone locks in. I just think the technology will advance to the point where even without having to, like, spend a shitload of government money on it, it will just happen, and someone will just do it because publicity and, like, you know, hey, look, I'm the first person on Mars, right? That's like you know, you'll be remembered forever, right? Just like how fucking Neil Armstrong's gonna be remembered forever as the first guy on the moon, right? Except even bigger.
Except even bigger.
Yeah. But will we ever leave the solar system? Absolutely not.
No.
People don't realize how big the solar system actually is. Yeah. That, like it's like as the further you go out in the solar system, the more exponential the distances between everything becomes.
Ah.
It's like going to Mars would take, I think, like 7 months at current speeds. I dashed. I pressed the dash button. Anyway, going to Mars would take like 7 months at current speeds. Going to the moon takes a few days. Going to like Saturn or something would take like years.
Why are we going to Saturn?
No, but like just for like you know, a planet that's far out.
Oh, okay.
Would take years and years and years. Going further than that, right? Like Voyager 1, which hasn't left the solar system yet, mind you. It's still in the solar system. Technically. Has been going since the 1970s. And it's going a lot faster than any human rocket would go because, you know, it's not got any people on board. And it's been going for 50-something years. Yeah. That's how big the solar system is. And it hasn't even reached the edge of the solar system, which is called the Oort cloud. It's called, yeah, you never hear of it, right? No one ever heard of this. You hear the asteroid belt. Maybe you hear of the Kuiper belt, right? I don't know. Have you heard of the Kuiper belt before?
No.
It's where, like, it's essentially where Pluto is.
Oh.
Like, close enough. Pluto dips in and out of it.
Okay.
It's the asteroid belt 2, edge of the solar system, Boogaloo.
Okay.
And it's like a second asteroid belt right at the edge of the solar system after all the planets. And then you keep going for a while. Like a while. A really long time. A lot longer than even reaching the Kuiper belt, which is, you know, around the distance Pluto is, right? You go even longer, a lot longer. And eventually you'll reach the Oort cloud, which is just a bunch of, it's basically an asteroid sphere. Not a belt, because it's not close enough to the sun to be squished into a plane like all the planets are. All the planets and the asteroid belt and everything are squished into a plane, more or less. Just because, like, orbiting stuff just works like that. But once you're at the once you're at the Oort cloud, you're so far away from the sun that doesn't happen anymore. And it's like a sphere surrounding the entire solar system of just, like, rocks that are barely held in the sun's gravity.
Oh.
It's basically the border of this rock is going to be trapped in the sun's gravity, and this rock isn't going to be trapped in the sun's gravity. That's what the Oort cloud is. It's so far away. It's so far away.
Okay.
Like, it's ridiculous how far away this thing is. So yeah, we're never leaving the solar system.
I'm okay with that.
Yeah.
Yeah.
Going in from the back. Yeah, you guys can just chill.
Huh.
Yeah.
Wow.
Going in from the back.
That was not awkward.
Nope. But I don't know. Space cool.
Space is cool.
Space is cool.
Space is cool.
And big. Really big.
Yeah.
Like everyone says, oh, space is big. You have no idea. You have no idea.
Yeah. Unfathomable.
Literally.
Yeah.
We have no idea how big it is.
Yes.
We don't know. We can't know. We can never know. The most we will ever know is the observable universe, and even then, we have no idea how big of a proportion, like, that is of space.
Oh, I was about to say, surely that's like a tiny...
Well, it could be most of space. We have no idea. The safe assumption is it's an absolutely tiny, abysmally tiny part of space, yeah.
That seems realistic.
It's 90 billion years across. 90 billion light years across. The galaxy's 300,000. So that is 3 million... am I getting that right? 3 million? No, 30 million galaxies across. That's big.
That is big.
That's real large.
Quite big.
Yeah. It's a big number.
Yeah.
It's so big that we had to build a bigger number than a light year. Called a parsec.
Oh, yeah.
Now you'd think, right? A light year is like 1 trillion kilometers. A parsec's probably like 1 million light years. How do I not get enough? Oh, how do I know, you know? If the universe is 90 billion light years across, well then, surely a parsec's like 1 million light years. 1 billion light years. It's 3 and a bit. It's like 3 and a quarter light years.
What's up?
Yeah, it's about 3 and a quarter light years. There is a reason that I went to the wrong floor. There is a reason why it's that size. It's something to do with looking at how stars move in the sky as the Earth rotates around the sun. Which is because stars, you can see them in the sky, right?
Yeah.
The Earth moves around the sun. It moves pretty far. So if you look and you measure a position of a star in the sky in summer, and then you measure the same star in winter. What? What? Brought us no bugs. Brought us no
I
bugs.
don't even know what happened.
My camera just flipped upside down. Some bullshit to do with the portal here being activated on Whiplash. Sometimes it's meant to be activated when you use this. And it's not meant to be activated when you hook point the Maurices. But this game works. Anyway,
Okay.
you can measure like stars moving in the sky, like as the seasons change, because the Earth moves, which is cool. And using that, you can like get like a distance, how far away it is, and that's how we know that like stars close to us, so like a few light years away. Anyway, I'm pretty sure that's where parsecs come from. I believe, I think, which is why it's a really silly tiny distance, because well, you can't measure stars that are very far away with that method. It just doesn't work. Yeah.
Yeah.
Do you want to know how we do? Do you want to guess how we measure stars that are really far away? How do we know that is? How could we possibly know that this star is 3 trillion light years? It's not. But how do we know that stars are a few hundred million light years away? How could we possibly know? We use supernovas.
Okay.
Yeah. We use a specific type of supernova called like a... It's like a type like 2A or something. I don't know. It's 2 something. It's something like that. We use a supernova, and you can use that to like do some bullshit that's beyond my comprehension, and you can find out how far stars are away. Yeah, it's pretty cool.
Okay.
And there's a cool story of you know how like light bends, right? Like light can bend with enough gravity. It does that a little bit. It curves a little bit.
Yeah.
There's an interesting thing because galaxies are very big. Big boys, galaxies are. They can curve light, right? Because they're so big. Or like a big black hole can. This is a real thing that we can use.
What?
Measuring shit.
Oh.
It's called gravitational lensing, and we discovered it existed, I believe. There was a supernova, right? Really far away. And it happened in the it was like a few decades ago, I think. And then that same supernova happened again, a few years later. The exact same supernova appeared again in the night sky. And then it appeared again, a few years later. The same supernova. And then now, right, scientists are like, what the fuck? Right? And then someone realized there was a perfect alignment of galaxies between us and this supernova. So the galaxy bent the light of the supernova in just the right way, so that like different, the light arrived at different times. And they could calculate this. They could calculate it to the day, I believe to the hour. I don't know if it was I think it was to the hour. That the next supernova would appear, because they knew there'd be another one. So they did a few calculations, and they said, right, okay, the supernova will reappear on this day at this time. It did. It did. They were right. Which is fucking crazy. And you can use it to like measure things and calculate things with a lot of complicated a lot of complicated maths. Oh boy, it's beyond me. Like, that's cool.
That is cool.
That's really cool.
Also, crazy maths.
Yeah, it's insane. I believe it's called gravitational lensing. Does it have a name? I think it's like Einstein's something. I don't remember. But that's cool. You can find a picture of it online. Maybe I'll put the picture up again. But you can very distinctly see there's like a galaxy, and there's 4 really bright spots surrounding this galaxy, and they're all just the same thing, but like bent different ways.
Einstein's general theory of relativity.
No, that's no. I mean, it uses that. But no, don't worry about it. Gravitational lens. Oh, look at that. No, it uses relativity, but it's some bullshit basically.
Okay.
Yeah. But yeah, isn't that cool? You can That's so cool.
That's pretty cool.
That's so awesome and so cool.
Cool.
Yeah, and you can like find the image of that supernova online, I'm pretty sure.
Oh shit, are you gonna put that up?
Why not?
Why not?
You can distinctly see like 4 bright. I don't know if it is that supernova, but you can. There's an image where you can. I went on the wrong fucking.
Ball.
Yeah. There's an image you could see of like 4 bright stars around a galaxy, and it's just 4 of the same supernova that's been copy pasted by the galaxy bending it. It's like, that's sick, dude. That's so cool. Yeah.
Wow.
Isn't it so awesome?
That's so cool.
It's basically so much weird bullshit.
It does.
So much weird bullshit. Too bad it's all unimaginably complicated. And Loki probably will never actually be useful to any of us in our lifetimes, but it's cool.
I don't know if it's appropriate.
What?
I do remember, like, when I told my parents, like, oh, my boyfriend does astrophysics. They're like, he's not learning anything about this world.
Yeah.
Yeah.